Hello everyone, welcome to the interesting time of learning ECG together. This is Talent's Virtual ECG Training TVET YouTube series. This video focuses on ECG diagnosis of atrial size abnormalities. I am Ogunlade, and at the end of this video, the viewer should be able to understand how to use ECG to diagnose right atrial abnormalities, left atrial abnormalities, and biatrial abnormalities. In doing this, the focus shall be on P wave. The reason for this is that P wave represents wave of atrial depolarization. So, this lecture we shall be dealing in details with P wave analysis. And in analyzing P waves, all the leads are considered, but special attention is given to leads 2 and V1. Lead 2 and V1. Lead 2 is a bipolar limb lead. V1 is a unipolar chest lead. The choice of these two leads should be considered. Lead 2 is chosen because it is oriented parallel to the mean vector of the P wave, and as such, one can study the duration, the amplitude, the configuration of P waves prominently in lead 2. On the other hand, V1 is oriented perpendicular to the mean vector of the P wave, and this is unique in the sense that in V1 the right atrial vector is separated from the left atrial vector. So it is important because one can distinguish and see right atrial abnormality from left atrial abnormality. So let's take the presentation of P wave in each of these leads. Let's start with lead 2. P wave analysis in lead 2. P wave analysis in lead 2. This is P wave. We put it in the context of the QRS complex. In analyzing the P wave, we consider 3 important components. The first component to consider is the configuration, which is the shape of the P wave. So we look at the configuration, shape of the P wave. With regard to this, the normal P wave in lead 2 is monophasic with rounded contour. It's upright, monophasic, and it has a rounded contour. This shape is a sum of the wave of atrial depolarization, and which is consisting of right atrial depolarization and left atrial depolarization waves. As such, we can examine the components of this configuration. The first component represents the right atrial depolarization. Right atrial depolarization. Whereas the second component, which is the latter component, so represents the left atrial depolarization waveform. So the unique configuration of monophasic P wave with rounded cutoff, so it's a summation of right atrial depolarization waves and left atrial depolarization wave. The second aspect that we consider is duration of the P wave. Duration of the P wave. So we analyze this duration from the onset of P wave to the end of P wave. So that is the duration, and this duration should be less than 0.12 seconds. Normal P wave duration is less than 0.12 seconds in lead 2. The third component for analysis is the amplitude, that is the height, the amplitude of P wave. So it is important to analyze it. So it is from the onset to the peak. There is a peak here to the peak. So amplitude so the normal amplitude of P wave in lead 2 is less than 2.5 millimeter. In summary, we have looked at the characteristics of P waves in lead 2, examining 3 components: the configuration, which is summation of the waveforms from the right atrial and left atrial depolarization waves. So it is upright, monophasic with rounded cutoff. The duration of the P wave should be less than 0.12 seconds, and the amplitude should be less than 2.5 millimeter. Any deviation from these characteristics will point to atrial size abnormality, which we consider in detail. So we move ahead now to see the presentation of P wave in V1. So look at presentation of P wave in V1. P wave in V1. The shape is biphasic. Shape is biphasic. So V1. So this is a KRS complex in V1. So then T wave. We are focusing on P wave analysis. So there's a P wave here. It's biphasic. It has initial positive deflection. This is positive deflection representing the right atrium, and the terminal portion is a negative deflection representing the left atrium. So that is why the shape of the P wave in V1 is biphasic. Initial deflection is the right atrial wave. Then the terminal portion of this deflection, so is the left atrial wave. Left atrial wave. And so as such, we could say that V1 enables us to separate right atrium from the left atrium. And this gives us room for more assessment. So normally, the right atrial portion is positive with rounded curve, very small amplitude and small duration. But for analysis of the left atrial components, there's a measure called P terminal force or Morris index. So, and this will be considered in assessing P wave in lead 1. Morris index, which is a product of the duration and the depth of the negative deflection of the P wave in V1. So Morris index. So let's look at how it is assessed. So we look at the duration, call it X. Call it X. And the depth. So call it Y. So Morris index is a product derived as X times Y. X times Y. So normally this product is less than 0.03. The unit is millimeter seconds. So since the duration is measured in seconds and the depth is measured in millimeter, so millimeter seconds, so that is the normal configuration and presentation of P wave in V1. Deviation from this pattern also reflects atrial size abnormalities. Let's consider these deviations first in lead 2, then in V1. P wave analysis in lead 2. Let's consider right atrial abnormality. So it presents with peaking of P wave. Peaking of P wave and increased amplitude of the P wave. So the first wave that look like this R wave is the P wave. Is peaked, is tall. The amplitude is smaller than 2.5 millimeter. Amplitude is more than 2.5 millimeter. So this is the amplitude. So for this one now, so the amplitude is 1, 2, 3, 4. That is 4 millimeter. And the shape is caret shape. That is inverted V. Is peaked just like this R wave. So, but the duration is normal. The duration of the P wave is normal. So, and this reflects right atrial abnormality. So this is the P wave. is the P wave. So we have assessed the P wave here. The duration is normal, but the shape is peaked. The shape is peaked and the amplitude is increased. So that signifies right atrial abnormality. Right atrial abnormality. And the classical pattern is called P pulmonary, that is seen when there is right ventricular outflow tract obstruction, or when there is pulmonary obstructive pulmonary chronic obstructive pulmonary disease, COPD. So right atrial abnormality. Let's look at another scenario, which is left atrial abnormality. Left atrial abnormality. Look at the P wave configuration, duration in lead 2. In left atrial abnormality, the P wave of normal duration, but the configuration will be bifid. Bifid configuration. Then let's look at the KRS complex. So looking at this picture, the first deflection, that is M pattern, that is bifid shape, is the P wave. So this is the P wave. This is the P wave. So this is KRS complex. So have Q here, Q R S T. So this P wave is abnormal. It has a long duration. So look at the duration. It's long from here to here. So the duration is long, more than 0.12 seconds. More than 0.12 seconds. For this index case now, 1, 2, 3, 4. So almost 5. So the duration is more than 0.12 seconds. But the amplitude is normal. The shape is bifid or M-shape in such a way that the duration from the peak, the distance between the two peaks, the distance between the two peaks of the P wave will be more than 0.04 seconds. This duration is also an important index for left atrial abnormality. So the duration of the entire P wave, is greater than 0.12 seconds, and the distance between the two peaks of the P wave is greater than 0.04 seconds. So when these criteria are met, that is left atrial abnormality. Take note, the duration, the amplitude is normal. Then another scenario we like to talk about is when there is biatrial abnormalities in lead 2. Let's consider that situation when there is biatrial abnormality. So in biatrial abnormality, the P wave will be tall, will be broad and tall. Broad and tall. So this is an example. The first wave here, the first wave is the P wave. You could see the P wave is broad. Duration now here is 0.16 seconds and is tall. The amplitude is more than 2.5 millimeter and it has a little notch, so it's broad and tall. So when there's biatrial abnormality, the P wave will be broad and tall. So duration greater than 0.12 seconds, amplitude is greater than 2.5 millimeter. So this is biatrial abnormality. Biatrial abnormality. So in summary, we have examined lead 2 to determine atrial abnormalities. So the first one is right atrial abnormality, in which the P wave is peaked, tall, where we have a narrow base. The duration will be normal. The left atrial abnormality, in which the P wave duration is long, greater than 0.12 seconds, but the shape will be bifid or M shape in such a way that the not only that the duration is greater than 0.12 seconds, greater or equal to 0.12 seconds, then the distance between the two peaks of this will be greater than 0.04 seconds. Then, but the amplitude will be normal for biatrial abnormalities. So the P wave will be broad and tall. Let's look at lead V1 to see how we can use the shape and the duration of the P wave in V1 to diagnose atrial abnormality. So we start with right atrial abnormality. Right atrial abnormality. The first portion will be peaked. The first portion of the biphasic P wave will be peaked. So, and the second portion will be normal. So, normal. This is V1. V1. KRS complex. So T wave. So usually V1 present with dominantly negative wave in its KRS complex configuration, but today we are focusing on the P waves. So this is the P wave is biphasic in such a way that the first component, which is the right atrium, so is peaked. That's the right atrial abnormality. Right atrial abnormality. So it's reflected in the first component, which is peaked, and the second component is normal, which is the second component, which represents the left atrium is normal. So we look at the left atrial abnormality. Left atrial abnormality in V1. So it's also biphasic, but the first component is normal. So, but the second component is broad and deep. So it's broad and deep. This T wave. So looking at this picture, the first component is positive deflection, is the right atrium. The second component is the left atrium. It's broad and deep. So, but to do justice to this, we need to assess the P terminal force, the Morris index. So this is P wave, is biphasic. So let's look at the P-terminal force assessment. So this can be done by determining the x, that is the duration, that is from here to here. So that is the x. Then we also look at the depth, so which is y. So we get the product, the P-terminal force. So P-terminal force, so which is the product of the x and y. So this is greater or equal to, this is greater already than, it's greater than 0.04 millimeter seconds. Because if you look at this component now here, 1, 2, 3, that is 0.12, then times, so this depth in millimeter, 1, 2, so times 2, so that is it's greater, the product is greater than 0.04 millimeter seconds. That is how to diagnose left atrial abnormality in V1, left atrial abnormality. So the other thing we need to consider is biatrial abnormality, how to make the diagnosis in V1, biatrial abnormality. So it represents with peaking of the initial components and deepening and broadening of the terminal components of the KRS of the P wave. So this one is KRS complex to contextualize it. So okay, T wave, it's our focus here. It's going to be on this biphasic P wave. This is P wave. This P wave. So look at the initial component is peaked, then this second component is broad and deep, showing biatrial abnormality. So the changes here is biatrial abnormality. So in summary, we have examined right atrial abnormality in V1, which is characterized by peaking of the first positive deflection of the biphasic P wave. We have also examined the left atrial abnormality, which is reflected by broad and deep negative deflection, in which the P-terminal force will be greater or equal to 0.04 millimeter seconds. Then we have also examined, rounded it up by examining biatrial abnormality, in which the initial portion will be peaked and the terminal portion, the P-terminal, is broad and deep. So if you have benefited from this video, kindly subscribe to my channel to get more video as we learn ECG together. Then moreover, to understand ECG analysis and interpretation, subscribe to self-paced TVET online ECG course series by clicking on this link. This will enable you to have access to TVET 100, which is fundamentals of ECG, then TVET 200, which is basic ECG analysis and interpretation, and TVET 300, which is advanced ECG analysis and interpretation.